Hello, Math 10. In Lesson 3, we are going to be talking about something very, very important that comes into play in almost all the things we graph in math. First thing they would like us to do is, point out what is the learner outcome here. It's going to be about finding x and y intercepts and how those relate to relations. And more importantly, what do those values actually mean when you have a specific relation? Reminder from the last one that a relation is a connection between two quantities. Height versus time, distance versus time, speed versus time. All those are relationships. A relationship can be represented by, in this case, ordered pairs. The first component of a set of ordered pairs is the x-coordinate, and also known as the input. The values of the input are values of the, in this case, we're going to call it dependent, the independent variable. Independent. So x is considered the independent variable, or you guys in science might call it the manipulated variable. And the second input, so the second variable of an ordered pair is the y coordinate, and it's also known as the output. And that is called the dependent. And I think in science, you guys call that the respondent. So it's important if I use the x value, and I'm going to make that green. So my x is this green axis here, and I'll consider this y axis, this red axis, and we do the same with each of these. Now as we consider this learner outcome of x and y intercept, they ask us the question, what are the coordinates where each graph crosses the x? And if you want to complete this and then come back and listen to the answer after, you may. But when we consider graph 1 and where it crosses the x-axis, clearly it crosses the x-axis at exactly this point right here, which is -3 and 0 for y. When we consider where graph 2 crosses the x-axis, it crosses at two places, here and here, at -2 and 0, but also at 2 and 0. And when we consider graph 3, it crosses at these 2 points, which are obviously -4 and 0 and 4 and 0. What do all these points have in common? Well, when you look at it, it becomes really clear that all these points have in common y equals 0. And that's really, really important to consider. I mean, we're crossing the x-axis, so when a graph crosses the x-axis, how high and how low is the point? Well, clearly that point is at a height of 0. When you consider the picture now, and we look at where does the graph 1 cross the y-axis? Well, it crosses the y-axis right there, which is clearly at a point of 0 and 5. And where does graph 2 cross the y-axis? Well, right there, which looks like that should be at the point 0 and 6. And graph 3 has two places. It crosses at 0 and -4, but it also crosses at 0 and +4. What do all of these points have in common? Clearly x equals 0, but I don't want you to memorize that. What I'd really like you to see is, well, why? Well, clearly when you look back at the picture, we're talking about where a graph crosses the y-axis. And where a graph crosses the y-axis you are on the y-axis. If you're going to cross the y-axis, clearly x has to be equal 0. You are not left, you are not right. If I'm on the y-axis, by definition, you must have x equals 0. And clearly, if you're on the x-axis, well, if you're on the x-axis, you cannot be up or down. You must be y equals 0. And that's important to remember or understand, because obviously we don't want to have to memorize that. We want to use it, right? When we go to the next slide, there's some important notes. How do we see the x and y intercepts off the graph? Well, to see the x-intercept of the graph, an x-intercept is the x-coordinate of the ordered pair where the graph intersects the x-axis. An x-intercept occurs where the y-coordinate is 0. An x-intercept can be given a value as an ordered pair, and we did that in the last section. A y-intercept is clearly, as you read it, is where the x-coordinate is 0. All right. Given the equation of a graph of a relation, how do we find an x-intercept? Well, if you were given an equation of a graph versus a picture, you find it by simply using what we learned before. If you want to know the x-intercept, you simply set y equals 0 and you solve it for x. If you want to know what the y-intercept is, you simply put in x equals 0 and you solve for y. Now, there's a little note here. You're going to see lots of different versions of equations, and this one, and this one, and this one are all the same. You can solve equations and manipulate things around, as you guys have learned over the years, and all three of those equations are the same. And we're going to investigate that later. For now, I don't want us to worry about that. I want us to basically use our equation skills. So in this question here, how are we going to solve this? So the key to this is that I know and I understand that an x-intercept is on the x-axis. That means that y equals 0. So if somebody gives me an equation, I simply say, okay, well, if y equals 0, therefore, I'll have 3 times 0 is equal to 5x plus 15. And that means if I take 3 times 0, that's still just 0. 5x plus 15, I take the 15 to the other side, and I have minus 15 is equal to 5x. And if I divide by 5 on both sides, I get an x value equal to minus 3. Therefore, I have a x-intercept that's minus 3, and the y value is 0. I know that this graph hits the x-axis at minus 3. For the y-intercept, what did I learn from our previous slide? I learned that if I'm on the y-axis, I must have an x value of 0. So I plug in x equals 0, and this one's even easier. I get 3y is equal to 15, right? Because 5 times 0 plus 15, that's just 0, so we get 3y equals 15, so that means that y, if I divide both sides by 3, so I'm relying on the things you learned from junior high, I divide both sides by 3 to solve for y, and I get y equals 5. So now I've got another point where I've got if x is 0, y is 5. Now, you guys learned about graphing relationships in ordered pairs. If now you go over here and you say, well, what does this actually look like? Well, interesting enough, if you plot those 2 points, minus 3 and 0, the x-intercept, 1, 2, 3. And if you plot the y-intercept of 0, 5, 1, 2, 3, 4, 5, you end up with a line. And that's what this relationship actually is. This relationship is really a line that looks like that. That's the line whose name is 3y is equal to 5x plus 15. That's what it looks like. When you plot it based on its x and y intercept, that's what you get. Pretty powerful stuff. You can now get to see what it looks like. And we'll show later how you can graph it on your calculator and so on. The equation for graph 3 on the previous page was x squared plus y squared. So you already saw a picture of it, but now let's pretend we never saw it. Let's pretend we haven't seen it. If all I had was the equation and I didn't know the picture, I use the properties of x and y intercepts, and that's what's really cool. I use the property of x and y intercepts, and an x-intercept, y equals 0. Oh, I better stay green. X-intercept, y equals 0. And that means that if y equals 0, I get x squared is equal to 16. You guys know from our radicals unit that if you take the square root of something now, you're supposed to remember that I need to take the positive or negative square root of 16, which is plus or minus 4. So I have 2 x-intercepts. One of them is 4, 0, and one of them is minus 4, 0. There are 2. But I also have a y-intercept. And if I'm going to find a y-intercept, I make y equal to 0. And if y equals 0, I get x squared equals, silly Mr. K. If I'm looking for a y-intercept, x equals 0. So that means that y squared is equal to 16. So that means that y is equal to, again, if you take the square root, you have to remember that you're taking both the positive and negative square root. And so you need to get an answer of both plus and minus 4. So now you have a point of 0 and 4, but also a point of 0 and minus 4. And if you plot these two green x-intercepts and two blue, whoopsie, don't want that one. So if I plot these two blue x-intercepts of 1, 2, 3, 4, there's an x-intercept, 1, 2, 3, 4, there's another one, and then my two blue 1, 2, 3, 4, 1, 2, 3, 4. How do you connect the dots of this relationship? Well, it makes the most sense to just make a circle. And that's exactly what that is. Based on its x and y intercepts, we now know that that's a circle. Yay, us. So it's really important as we do this unit on relations and functions. This has a lot of practical applications. The things we graph and so on should have meaning. They shouldn't just be abstract things that we just do for math. So this is an example of a practical application. So in this one, Lisa purchased a new car for $20,000. That's awesome. The value of this car is represented by this equation, where V is the value of the car in dollars and T is the age of the car in vehicles. Now you guys have done tables of values, so now the suggestion is, well, what value should we put in here? So we have to choose some different values to put in here. Now in this case, because we're just getting started, they've actually told you that the inputs you're going to put in there are 0, 2, 4, and 6 years. But in another situation, you might actually pick them all yourself. So in the first question, finish off the table of values. If you were to have a car of 0 years old, what would the value be? Plug zero into your formula, and what do you get? Plug all these inputs in. So when you plug 0 in there, you get a value of $20,000, not 2,000, but 20,000. And they want you, I don't have much room here, but they want you to write this, 0 and $20,000. That would be your point. The x value is time and the y value is value. So the manipulated is time and the respondent or the dependent one is value. In the second one, what about what happens at 2 years? Well, if you plug in 2, you end up with $17,500, right? So after 2 years, your car is worth $17,500. After 4 years, plug in 4, and if you're wondering how we're calculating that, I'm using my calculator. $20,000 minus 1,250 times 4. You're plugging it into that equation for value. 4 times 1,250 ends up being, I'm not going to do this with every one, but it ends up being $5,000, and therefore the value after 4 years is 15,000. And you continue on. After 6 years, it's 12,500. And what you want to do now is, well, what does this look like as a graph? Well, plot each of those points that we made here. And if you plot each of those points on the graph, and I just want to move this over, if you plot each of those points on the graph, well, what happens in terms of the picture? Well, I want you to take a ruler and draw an accurate line, but plot each of those points. At, for example, 0 and 20,000, right? So 0 and 20,000 is that point, and there's 2. And then the other one we had was at 4 years and so on. So at 4 years, right, at 4 years was this point right here. And then we had 6 years, I believe we had this one right here, which was 12,500. So those are exact points, 0, 2, 4, and 6. Right? And then they actually ask you some more questions. What does it mean at 0, 2,000? Okay, and you don't have to, if I were you, just do the lesson and then come back and look at it after. Don't, right? Think about these questions yourself. And maybe you have a different answer and we can talk about it in class. So what does the ordered pair 0, 2,000 mean? What it means to me is that 0 years old, it's the new car cost. But it's all